seems good. And let's see YouTube. Is it working? I think it is working. Hello, everybody. How are you? Yes, here we go. Sorry, I'm a little bit late. I just finished my meeting with the team, and so we are now live for another session of linked list. So this is gonna be my first time live streaming on both YouTube and let me put me on mute because I can hear me. Yeah, on YouTube and X. So I hope like people can see me on X. And here we go. So last time we talked about a lot of basics. I think this time we're going to talk about basics again. But we probably are going to incorporate some doubly linked lists. Volume low. Oh, is it the same for everybody? The volume is low for everyone. Okay, let me see if I can do something. Can I do something? Can I do something? I can do this. Here. Up. Is it better now? Is it better now? It seems to be better now. Is the audio better? I guess no more complaints, so the audio must be better. Not yet. I can't do a lot of I can't do much better than this. Can I do much better than this? Can I do this? Oh, you're gonna see the mic. Let's see. Here. Is it good now? I'm like right next to the mic now. Is it better? Okay, I don't think I can do better than this. I'm right next to it. Let's check. Yeah, I think it's fine. It should be fine, guys. The voice is good now. Okay. All right, good. So let's start. This is gonna be our first. Still low. No, I can't do better than this. Oh man. Let's see. Let me see if I change mic. Can I change here? Let's see. Can I change the mic? How do I change the mic? Oh, now better? Wait, is it good or not? Properties. Now better? It's cool now? Do hard things, yeah. But I want to make sure everybody here. Let's see. Let me change the mic to see if I can. Is it better now? Oh yes, this one seems much better. Is it better now? Is it too high now? It seems better now. 1, 2, 3 check. 1, 2, 3 check. Put 42 in the chat if you hear me nice now. If you hear me well. Good? Too loud? Man. Okay. It's okay. Good. All right. Good. Let's go now. 5 minutes to set up the sound. My God. Okay. So we're going to do some linked list again. So last week we did some like pretty basics. Were you guys there last week for the first one on linked list? Yes. Okay. Good. So maybe we're gonna go like a little bit faster this week, or maybe we just, you know what? Let's do like 1 or 2 functions just to like warm us up. Okay. So let's do like we're gonna use the same structure as last time. So what did we use last time? We used this structure for a single linked list. So we're gonna add like a prev to here once we go to like doubly linked list. But let's maybe like review like the basic, like how to add one node at the beginning, and then we do one node at the end if you want intricate C level. Okay, sounds good. So let's do that. So as always, before you want to code anything, you want to go to the whiteboard. Okay, and we're gonna review this like very step by step. So let's just say like this is a node. A linked list is a suite of nodes that links to themselves one by one. Okay, and then somewhere in memory you have a pointer, a variable that points to the beginning of the list, and the end of the list points to null. So basically, like inside each of those structure, you have a pointer to the next node, and to understand that this is the last node of the list, the value of the last pointers in the last node is null. So points to null, points to nothing. Okay, this is your way of knowing that the list is done. So in order to like, so at the beginning you have a variable, it could be like ptr, whatever, that points to your structure, and then you initialize it to null. So at the beginning it points to nothing. Okay, then what you want to add is a node, right? So you add a node, you create the node, you create the space in memory for the node with malloc. Okay, malloc is going to return a pointer to this node, an address of the node, and then what you're going to do whatever you want with those items that you have inside the nodes, and then you're going to make this point to the new node, and this one points to the previous first node, in this case null. Okay, so this doesn't exist anymore, and then once you want to add another one, you malloc again, and then you do whatever you want with this structure. Here you have the next pointer that needs to point to the previous first one, so now it's going to point here, and this one now is going to point to the new one. Okay, so you have like pointer that points to the first one, that points to the second one now, and that points to null, and so on and so forth. Okay, so we're going to try to code that first again, just to warm up, and then we're going to do we're going to add like this node at the end, and then we're going to do some doubly linked lists, and you're going to see like it's pretty much the same thing, except you have like two different nodes. Sounds good? I guess it's a yes. So let's go. So we're going to use this file, and we're going to use another main file, main2.c. We're just gonna copy the main. Here, add nodes. Yeah. Okay, here we need to include our linklist.h that contains the definition of that structure, right? So here we just need this one for now, and then we're gonna create the function add node. Okay, so add node doesn't return anything, and it takes as a variable, it takes list h, which is the head. Oops. Which is the head, which is the address of the first node. Since we want to modify this variable, Ah, you didn't see anything because I didn't switch the. I'm sorry, guys. I'm gonna restart. All right. Let's go again. How do I delete all of this? Okay. So let's go again on the whiteboard. A linked list is a suite of nodes that points to the next one. Okay. You know that this is the last node because the last node has a member that points to null. Okay. In our case, it's called next. Okay. And somewhere in your program, you have a variable. Here we call it h, like that points to the first one. So this is a pointer. This is the memory address of that first node. Okay. At the beginning, you have like a node, a list that is empty. So this points to null. Okay. Every time you want to add a new node, you need to allocate the space for it with malloc. So you create this structure, and then you do whatever you want with those fields. But here you have the next variable that needs to point to the next node, right? In this case, if we want to add this node at the beginning of the list, we want to say this one is gonna point to whatever h was pointed to, and then h is gonna point to the new node. Okay, so now h now points to the new node, that is the first one now, which points to null. Next time you want to add another one, you malloc again. You do whatever you want with the field, but with next, you want to make it point to whatever h was pointed to. So this one, right? So this is going to take the value of h, and h is going to now point to the new node. Okay, so now you have h that points to the new node, that points to the previous new node, that points to null. Again, third time, you malloc. You do whatever you want with those fields, but with the next, you want to point to the previous new node, which memory address is stored in h. So this is going to be here, right? And then h, instead of pointing to here, now points to the new one. So now h points to the new node that points to the previous new node that points to the previous new node that points to null, and so on and so forth. Okay? So when you want to create the function, the first thing you're going to do is you want to allocate memory for the new node, right? So which type is going to be list? So this is going to be an address returned by malloc. So new equals malloc of the size of the structure that you want to create in memory. Okay? Then we have like different things inside. The first thing is str, the second thing is len. So just like last week, we're just gonna do new str equals Julian for now, and then new len, which is the length of the string, is going to be 6 for now, and then we're gonna make it dynamic. Okay, but just for us to like focus on how you create this this linked list and you add a new node, I don't want to focus on this yet. Okay, so now like you know that new next we said is going to take the value of the memory address of the first node, which is stored in h. Okay, and now h is going to become the address of the new node, needs to store this. So this is going to be new, because new is the address of the new node. Okay, and that's it. So normally if we add those, we should have we should have added, sorry, 3 times Julian into the linked list. Make sense? Okay. So let's just run it just to make sure that it doesn't crash. So gcc, so what, like main2.c. Okay, so it works. If we run it, nothing's gonna print because we haven't printed anything, right? So the other function that we need to make sure that this is working is a function that prints the list. Prints list. And here we're gonna pass as an argument list th. Okay, so how are we gonna do this? So here we want to print each node at a time, okay? One after the other. So first we have h that points to the first node. So we have a pointer here, which is h, that points here. So it's very easy to access, the data here, and so we print it. Now we want to get to the next one. So how do we get to the next one? We have a pointer here called next that points to the next node. So we're going to move this pointer to h next. So this is going to be h next. Okay, that's how you do it. And then h equals h next, and then this is h now, and then you do it again until you hit a next that is null. When next is null, you know that there's no more node to print, and so you stop printing. Okay, so let's go back to the terminal. So while h, so as long as h is not null, right? Or we could say same thing here, is not null, you're gonna move from one node to the other, h next. Okay, and here we're gonna say h, we're gonna print print string, and then the size. Is it an unsigned int or is it yeah, unsigned int? It's gonna be a u. So this is gonna be h str and then h len. Okay, and so here if I print it here, I should have like 3 times Julian. Okay, makes sense? Okay, Julian 6, and Julian 6. Any question about this? It's pretty straightforward. Why a double pointer? Intricate. So I guess you're talking about... Oops, sorry. I guess we're talking about here, the add node, right? So the thing is that we want to modify h, right? You remember h needs to take the memory address of the new node. If we pass only h, then h is going to be modified here, but not from the main function. So as soon as you go back to the main function, then h disappears. Okay, so you need to take the address of the variable you want to change, because everything is passed as a copy. And it's true also for pointers. So if you pass a pointer, you're going to pass the copy of that value, okay, which is the address of the new node, but it's not the address of the variable you want to change, which is h. So you want to pass the address of that variable because you want to change it. Does that make sense? Intricate, does that make sense? Okay, okay, sounds good. Thank you. Any question about like the rest of the program? It's pretty straightforward. This is what we've done last week. So the other thing we done last week is we want to add a node, but we don't want to add like always the same thing. So here we're gonna pass a different string every time, okay? So maybe we're gonna pass intricate syllable here, and here we're gonna pass Mutala Muji, and here we're gonna pass, who else wants to join? John. Okay. So now we need to duplicate this string here to put it inside the linked list. All right. So here we're gonna need to create str duplicates. Char star str. So we need to duplicate this string here. So we're gonna create this function here. So char star str dup char star str. So what do we need to duplicate a string? First, we're gonna need to allocate enough memory to create this string into the memory, and then we need to copy the previous string into this new allocated memory, right? So the first thing we need to know is how much space do we need to store the string that we want to duplicate. Sounds good? So we're going to know the length of the string. So we're going to have to create the function length. So strlen of str. Okay, so this one is an int, strlen of str. So how do we count the number of chars of a string? We go from one char to the other until we hit the 0 char, right? Again, I'm going like faster than last week because we've seen this last week. But if you have any question, please like post it on the chat, and I'll be happy to go to the whiteboard to make this happen. So int len, we start at 0. And then y str, then plus plus, and then we move str by 1 2 to the next one, and then we return length. Okay, so now that we have the length, we can allocate the new string. So new equals malloc of size of char multiplied by len plus 1. Okay, why the plus 1? Because at the end we want the character 0, right? So once we have this, then we can copy our string. So we can do str copy of new str, and now we need to create this void str cpu y of char star to char star from. And now what we're going to do is that we have like 2 different pointers, one at the beginning of each of the strings, and then we move on and copy one at a time until we hit the \0, right? So basically y from then from plus plus we move on by one at the end, and then 2 equals from, and we also need to move this. Okay, once we are here, then it means that we had hit the \0. We still need to put it into 2. 2 equals, okay, and with this we have copied our string into the newly allocated space, and then we just return the address of the string. Right? And with that, we should have like duplicated our string. Let's see if this works, and then I'm gonna answer your questions. Okay, so we're good. We actually have our strings. So you noticed that, this is the first node that we have added, the second one, and the last one. And since we added this at the beginning, it's normal, like each node at the beginning, it's normal that the last one added is the first one of the list. Okay. So now we need to fix this. This is the length of the string. And now we have like a function for this, which is strlen. Okay, of str. All right. Any question? No question. Whoa, okay. There's a question from the previous function. John is asking, when next is null, can you like point back to the first h, which was pointing at null instead of pointing straight to null? When next is null? I'm not sure I understand the question. When next is null? When next is null? Can you point back to the first h, which was pointing at null, instead of pointing straight to null? John, I'm not sure I understand your question. I'm sorry. Ali is asking why you don't give h variable null in the declaration level. I do here. It's important because otherwise you don't know what is going to happen to h. Once you declare variables, you have no idea what it is. It's not set. So it's important to start at null, to say, okay, like this is null. It means that our linked list is empty. Okay, no question? No more question? Okay, all right. So what you wanted to do is like add a node at the end. You want to do this one? So let's go to the whiteboard and see how this is going to be different from add node at the beginning. Okay, so add node at the end. So let's take the h pointing to like a small linked list first. Okay, it could be like more than one. Essentially, you're gonna have to first create the nodes with malloc. That's for sure, right? That doesn't change. Then you do whatever you want with all those fields, and then you have the next here. But next, this time is gonna point to null for sure, because you want to add it at the end. Okay, so you can already initialize this here. H is not going to change in this case. There's like the special case where like h is null, but in this case, like where it's already a linked list, it's not going to change anything, right? So what you need to do is basically have like another pointer, like p, walk through all the nodes one by one until you hit the one that points to null. So this one is the last one, the current last one. Now what you want to do is have this one point to the new one, okay? And then nothing else, because this already points to null. Okay, so it's just like having a pointer walking through the entire list, hitting the last node. Once the last node, you know it's the last node because it points to null, and you replace the next pointer with the memory address of the newly allocated node, which now is the last one. Okay, and there's the special case where like h points to null. So you're gonna have h here, you're gonna have p that points to null directly. So in that case, you want to have h points to null, and that's it. Okay, so you can't walk because you're already there. Okay, so you have like a special case for the beginning, but then once you have like at least one node, this one points to null, then you know that p next is null, so you don't walk at all, you just stay here. And then again, like this points to this one, and this one already pointed to null because you know it's the last one, so it needs to point to null. Okay, so let's just code that. So how do we translate that into code? So at end. So same thing, we're gonna do all of this. Okay, so you allocate the new node, you duplicate the string that you want to insert, and then you have the length, and then you know that a new next is null. Okay, so far we just had done this part. Okay, let's just clean it up. So we have an h that points to our linked list. Okay, and then what we have done is just malloc so far. Malloc, we've done everything we needed here, and this points to null now. So what we said is that now we're going to have like a pointer that points to the first node, and like we're going to walk until we find the last one that points to null. Okay, so this is the second phase. So we'll need a pointer, and we decided to call it p. So p equals h for now, and then while p next is not null, or p next, we're gonna walk through it. So p equals p next. P next. Okay. So what we've done with this part of the code is just this walk. Now we know that p next is null. Okay, so we know that p points to the last node. Okay, so now what we need to do is we need to have this node points here. So p next needs to be equal to the memory address of the newly allocated node, so new. Okay, we have new that points here. Make sense? So now we know that p points to the last node. Okay, so we need to change p next, and p next needs to be new. Okay, so now what we've done with this is that p next, so now this one points to new. Okay, it no longer points to null. So like this is done. So now if we print again, we should have all our nodes, the previous nodes, and this one at the end this time. So let's see if this works. So we have a print And add node ends to take the address of h to be able to. No, we don't need to take the address of h actually. Oh yes, we're gonna need to for the second step, for the special case, sorry. And then print list again. Just gonna printf separator here. Okay, and here is going to be here. So here, this was my previous list, and here I added Abdulrahman Motawa at the end. Oh man, always like. So this is like the walkthrough again, and then I just updated p next to new. And then I just printed the list again, and I added someone else here. And when I run this, I have my previous list printed here, and then I use the same list, but this time I added the last item at the end. Okay, but now this is not going to work with a list that is empty, right? What happens if the list is empty? Do you have any idea? What happens if the list is empty with this code? Who can tell me what's going to happen? Oh, you guys want a Naruto background for next time? I'll try to do something with Midjourney again. Yes, Ali, it's going to segfault, right? It's going to segfault. Where exactly? It's going to segfault here because P is going to be null. So you're going to try to deference like the null pointer and it's going to crash. Okay. So there is like this like special case that we talked about. The special case being when H is points to null. When H points to null, what you need to do after you malloc, so you still malloc, right? Malloc, this is the worst and worst. Okay, this still points to null. Same thing, same code. And then P points to null. So if P points to null, what you need to do is have H points to the first node. Okay, so in this case, if H or P equals null, then you have H, you modify H to point to the first node of the linked list. Okay, this is the exception. So this is what we're going to do. How does it translate exactly? So P equals H, and then if P equals null, then you have H equals new. Else, you do the rest. Okay? And this should work even for null. So let's do it again with null. All right. And then here we're gonna have who wants to be a node today? Desmond wants to be a node. All right. So here it's working even for a null pointer. All right. Any question? So like, you know, like adding at the end, like is a little bit more complex than adding at the beginning. But really like when you take it one step at a time, it's pretty clear what needs to be done, right? I think, you know, one of the things you really want um, to understand from that live coding session is I never go straight to the code. I always go like first to the whiteboard, make sure that I understand the, you know, what is asked, and then like step by step I go to the code. I don't do everything at the same time, step by step. Okay? Do you guys have any more question? No? All right, should we do like a doubly linked list? Okay, why and when we use singly linked list. So you use linked list when you're gonna have like input from an outside source of your program, but you have no idea how big it's gonna be. If you know like how big it's gonna be, then you can just use like you know, like an array of structure. But when you have no idea how big it's gonna be, you need to be more flexible, and linked list is, you know, one of the way to go about it. So searching through a linked list, it's linear. So it's like ON. You have to go through all of the list, you know, one by one. Yeah, linked list is, you know, it is dynamic, right? Okay. Yes. Oh, you want to delete a list? Or you want to pop? Okay, we can do pop. How do we pop? So let's pop a list. So pop pop is oh, let's go back to the whiteboard. Okay, so you have H here. That points to a node, that points to another node, that points to another node, etc. And then at the end you have null. So pop is like you want to take the first one, extract it, and then delete it from the list. Okay. So basically you have like H that points to the first node. Okay. And then, so you know the address of this one. So you want to have a pointer to this one to remember where it is, because H needs to point to the next one now. And then what you do is that H now points to this one's next. Okay? So pretty easy. And then of course there's like the special case where H is null. Like you can't pop anything, right? So you pop is gonna equal to null probably. Okay? So we can pop. Let's pop. Let's pop. How do we translate that into a pop? So list is going to return a pointer to the pop structure. So pop. Up. H, you're going to need to modify it, so you want to pass the pointer to it. And so essentially what we said is that you want another pointer. It's going to be the pop pointer, but it's going to point to the first element of the list. So pop equals H, right? And then if pump equals H here, and then if H is not null, what we said is that H needs to point now to H next. Okay, so H equals H next. And then you return pop. Okay, and that's it. And like with this, we have taken also into consideration the special case, because pop here is null if H is null. And you're gonna do this only if H is null. Okay? So let's see if this works. We're gonna add node, add node, add node, and here we're gonna pop here. Let's just pop here. Pop. Pop the address of H, and we should have only one left. We should have removed one, sorry. So here, this was like the list before we popped it, and now this is the list after we popped it. So this is right here. Okay. Any question about the pop stuff? So Elijah, you're asking like when we add like strings, we allocate memory once. Other instances where we free the memory. Yes, when you want to like free the list, then you want to free everything that you have allocated for it. The pop shouldn't it delete the popped node? Depends on the definition of your pop. In mine, you don't do it, but we could also like free it if you want to. So if you want to pop and free, Redwan, let's do pop and free. So pop and free. So pop and free. So in this case, you don't return the first element. You return nothing, just like on a free it. So you have here H equals H, and then you don't return anything. And essentially then if here you're just gonna free pop, because this is the part you allocated with malloc, right? But inside you also allocated two other. Oh, sorry. Remember when we did the add node, we allocated the structure, but inside the structure we also allocated for this string. So we need to free it as well before we free the node. So pop and free. So we free the node here, we free the structure that we allocated with malloc, but this one we also want to free. We want to free str. So we can check pop and free. Pop, 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 pop. Where is it? Pop and free. Okay. So we have popped it, but we have freed it also. Does it make sense? So again, if you want to pop and free, you think about how you pop it, and then you free it. You know, one step at a time. Don't do everything at the same time. Just go to the whiteboard like one step at a time, and then like you solve for one step at a time. Should we do some doubly linked list also? Yes? All right. Let's do some doubly linked lists. Oh no, we wanted to like free everything first. Do you want to free the entire list? Should we free the entire list? Or do you want to free the entire list, or do you want to do like doubly linked list? What do you prefer? We have like 20 more minutes. What do you guys prefer? Free. Okay, you want to free the list, the linked list, the entire linked list? Double. Ez wants double linked list. And Elijah wants free. Ha. Okay, let's free the list and then we do like a little bit of double linked list. Okay. So we have h that points here. We want to walk through each of them with like a pointer, could be h if you wanted to. You know, we're going to use next to walk through it until we hit null, then we don't want to free null. By the way, what happens if you free null? Do you have any idea? So you have a pointer here, you point to the next one, and then you free it, okay? So now, by the way, like we have done pop, so you could just like loop. It's like a pretty easy way to do it, right? We've done pop before. So we can just like pop until you hit null. That could also work. Like if you pop and free, and then here you return h. Oh no, you don't need to return h because you modify it. So if you do while pop and free, oh look, free list. Void free list. We need the pointer to the header, right? And then you can do while h is different from null. Then you pop and free. This is not very this is not perfect, but you know, it's reusing what we've done before. So pop and free, which is my free node, free list. Boom, nothing more. And then we can go to doubly linked list. Pretty easy. Just do pop and free until it's done. That's the actual algorithm actually. So like it's better like to have only one function, but you know, you can just reuse it and it works. Does it make sense? It's pretty straightforward. Like once you do it like step by step, like you know, then you have one step and then you loop through it. Okay. So I'm just going like a little bit fast here to be able to do like double linked list. We have like 15 minutes left, so I just want to do like at least one thing. Okay, let's go back to the whiteboard. Doubly linked list. So doubly linked list. Doubly linked list is really not that far from like singly linked list. Instead you have like one more pointer that points to the previous one. This one points to the previous one, and this one's gonna point to null. Okay, so how do you add a node? So you have at the beginning you have h that points to null. Okay, first step is going to be the same thing. You're going to have two malloc. Okay, and then you do whatever you want with the fields, and then you have one prev and one next. So let's just say you add it at the beginning. Okay, so if you add it at the beginning, the first step is going to be the same as before. The next is going to point to whatever value h was pointed to. Okay, and then h is going to point to the new node. Okay, and then prev is always going to point to null because this is the first node. Okay, and that's it. So it's really like there's not too many differences. So again, you malloc here for the second one. You do whatever you want with the fields. Prev is always gonna point to null because this is gonna be the first one. And then next is gonna point to whatever was pointed h2. So this node, right? So here, then you have h pointing to the new node. Then if you have like more than one, then this one needs to point to the new one too. Wait. I'm confused. Too many arrows. This is prev. Prev, yeah, needs to point to the first one again. Okay. So let's try to draw it a little bit better. So you have h. Step one. H that points to null. Okay. You malloc. Prev is always going to be null. And then next is going to point to whatever h was pointed at. So in this case, it's null. And then h points to the new one. Okay? Then step two. We have another one. So we malloc again. Oh, we want to add it at the beginning. Okay, let's put it here. Do whatever you want with it. Okay. Again, prev is going to always point to null because this is going to be added at the beginning. Okay. And next needs to point to whatever h was pointing at. Okay. So to this node here. And then prev of the previous one that was the first one now is pointing to the new first one. So to this one. Okay. So third step, to make sure everybody has understood, we had like this slim one, big ones. In memory, they're all the same. I'm just like trying to have like different sizes to make sure you follow. So next points here, this prev points here, this next points to null, and this prev points to null. You add the new one with malloc. Prev is always going to point to null because this is going to be becoming the first one. Next is going to come point to whatever h was pointing to, so to this one. And this one was now it needs to point to the new one. And then h needs to be updated to the new one too. Okay? So how does it translate into code? Let's see. Let's go back to code. Okay, so first we need like a new structure. Just gonna do the same thing here. Instead of having next, you have a prev also. And I'm gonna call it day list, like doubly linked list. Double list, okay. Day list t dot ph. So first of all, we initialize it to null. Okay, and then we're gonna add node double linked list. Oh, by the way, let's see if there's a problem with the null pointer. What do we do if h is null? If h, oh, we just did it. If h is null, we did it too, right? So it's gonna work same way. Just wanted to make sure that we covered that. Okay, so add nodes. We're gonna pass the address of it because we need to be able to change it, and then we're gonna add one of you, and it's gonna be browse that code. All right. So let's see. Add nodes at the beginning, and then we're gonna be able to copy a lot of things. No, add node. Where's that node? Here. Okay, so I allocate my new node, and this is a list, a delist, and a delist here. Okay, so this doesn't change. I'm allocating enough space for my list. This time is a delist, so I allocate enough space for a delist, size of delist. Okay, and then string doesn't change, length doesn't change the code. Then we know that all the time we said that prev is going to be null. Okay, and then the next one is going to be the one that is pointed by h. H is going to point now to new. Okay, what did we miss here? Okay, this is my code. Here, this is my code. Okay, so again, just delete all of this, some more space. So I have h at the beginning is null. Okay, then what I do is I malloc for the size of the new list. Okay, so somewhere in memory I have this block, and then I have str. I do what I need to with str, with len, with prev. So prev now points to null. Okay, and next now points to whatever h was pointing to. So it points to null, which is normal. This is the first element, so there's only one. And then h is now going to point to the new one, because this is new equals malloc. Okay, so h no longer points to null, so we have h that points to the first one. Okay, so now let's just say we add another one, and then this is here now. So I allocate, so this is like now new. Okay, and then I do what I need to do with str and len, and then I have prev that points to null, right here, all the time, and then next that points to whatever h was pointing to, so that points to this one, and now h points to this one. What needs to be done now? We missed one thing. Anyone? What have we missed? What have we missed? like one last thing. And yes, this is this one. Here, this prev should point to the new one. So at which step do we need to do this? We need to do this probably before we change H. So we can do, or like, yeah, because this was the previous one, okay? So before we change H, we go there. We can also like do like new next prev if we wanted to, right? Whatever works for you. So let's go back to the code and update this. New next, and then new next prev equals new. Okay? There's like one case where this is not gonna work. This is not gonna work if it's like only one there's only one element. Because if there's only one element, new next is null. Right? So we need to make sure that this is not null. So if new next is not null, we could do like if H is not null also. Then we do this. Okay. We could also do H next equals new. Like these are like the two things are the same because now new next is H. So H is the same as new next. Okay. Could do both. And this now should work. Okay. And we should be done with this. So let's just like call it once and see if it doesn't crash. All right. One is an struct list from incompatible struct type delist. Or is it new next equals H? New next equals H doesn't work. Why? Delist. Oh yes. Of course, we need to change it here too. And then TL undeclared. This is from main. This is TH. Oh, what did I do? TH. Okay. Okay, so it didn't crash. Now we're gonna add 2 more nodes, and then we're gonna have to do a print delist. Okay, let's add 2 more people. We're gonna add as, and we're gonna add Seba. Welcome to the doubly linked list, guys. Okay. So now we need to print it, right? So printing is going to be exactly the same as printing a single linked list, because we go through one to the other, and we in both cases we have the next. So we're just going to copy it. Print the list here. We have a next in both cases. No, it's not X, this is the list. And this should work. Okay, Seba as and browse that code. And then we're done with the adding a node to the linked list and printing it. Any question? Okay, as is asking, why do we make the prev points to null all the time? So the reason we're doing prev points to null all the time is because every time you're gonna add the node you added at the beginning. And so prev doesn't point to anything. Okay? In your linked list, in your doubly linked list, no. So you always have like a pointer to the first node, right? In your single and doubly linked list, you understand that the last node points to, like the next of the last node points to null because it doesn't point to a node. Same thing for the doubly linked list, the prev also points to null to tell the programmer that like this is the first element. So you can't go back because you remember you can go like from this one to this one, but also the other way. But like you don't want to go like this way. There's no more nodes. So like in order to like make sure that you know this is the first one, then you put prev to null all the time. If we were to add like the new node at the end, we would do like the inverse. Like this would be the next would always be null because we know that we want to add it at the end. Does it make sense? Okay. Any question? Okay. All right. We may have time for another one. Do you want to do a... What could we do? Do you want to do a pop? Well, the pop is going to be the same thing, right? Oh, we can do a pop. There's like one small difference. Intricate. It seems that adding nodes to either sides with doubly linked list is quite easier compared to singly linked list. I don't know. I think it's the same. Actually, like you have like one more element to update for the doubly linked list. So I would say that adding an element to singly linked list is a little bit easier, but the idea is exactly the same in both cases. Okay, let's do a pop and then we wrap this up. Okay. So let's go back to the whiteboard. Where am I here? Here. Where's my whiteboard? Here. Okay. So you have your doubly linked list. Okay, you have your doubly linked list, and then what you want to have, same thing as last time. Or this H. P is going to become the first one to save it, and then H is going to become this one. Okay. And then what we need to do on top of it is this pointer no longer should point to this old first element, because now this is becoming the first pointer. So this prev needs to point to null now. Okay, so everything stays the same except that you have to also update prev here. Okay, and so like the one thing you need to check, of course, is that H, after you move it to H next, is going to be not null. If it's null, then you don't want to update anything. You cannot dereference like H next. It's not going to work, of course. Okay. So how does this translate into code? Let's do a pop here. Okay, so delist, I'm going to depop, delist. Okay, so you have pop that points to the first element. Okay, if h is not null, then h equals h next. And also before you do this, no, h equals h next in any case. And what we said is that if, again, h is not null, if it's not, an empty list after you pop it, then what you do is going to be that h prev equals null. And that's it. Okay, so let's just review it. Let's just look at it on the whiteboard at the same time. Okay, you have your code here. You have h that points to the first element. Points to the next, points to the next. Okay, prev points to the previous one, prev points to the previous one, and prev points to the previous one, and this one points to null. Okay, so you say pop. Here we say pop equals h. Okay, so pop points to the first element. Now, if h is not null, right? If this is not an empty list, if it was, otherwise it would be just this. Okay, if it's not null, then h, you moved it to h next. H next points here, right? So now h points here and is no longer pointing here. Okay, then you say, okay, if h now that it has moved is not null, then you're gonna update prev here, h prev to null. Okay, and now you can return pop if you want it to pop in this way. So pop points to this one. This one is like an element that is no longer part of this doubly linked list. Okay, and that is all for today. Do you guys have any last question about this? It's pretty straightforward, right? Again, especially when you work with pointers and when you're not used to them, go to the whiteboard, draw one step at a time. And it's gonna make your life much, much, much easier. All right, if you don't have any more question, I'm gonna tell you goodbye and I'm gonna see you soon for the next one. And there's been a lot of requests on different things. So printf live or other stuff, just let me know in the comments and we'll see what we can do, and I'll see if we can do that in the next 2 weeks.